What's up everybody, this is Evan from acesprogram.com, and I decided to make this video today to show you how I used art to learn some mathematical equations, values, and some other interesting things. I will give you a brief explanation for why I use this method and also how it works. So I guess we'll get into it. Here we go. As for why I use this method to learn math, well, our educational system is failing, as evident by the plummeting of our global standings and academic proficiency. Our school curriculums are not keeping up with academic progress, which creates bigger and bigger gaps in the necessary knowledge to be proficient at entry-level jobs. And probably the biggest reason is that the ongoing opinion of school is that it's boring. If we want an educated populace, we need to make students excited about school. When the educational system fails to adapt and students are, bored with it, the students have to leave it behind and use autodidactism or self-education to satisfy their curiosity for knowledge. For-profit colleges are extorting the population, and our educational decline is the result. Education should be free and completely voluntary, and for those reasons, that's why I'm using this method, using art to learn math and science. Now, as for how this learning method works, it's actually pretty simple. The more neural connections that a memory has, the stronger that memory is, and the longer it lasts. So instead of just staring at two-dimensional numbers written on paper, you should be experiencing math in a three-dimensional environment. And you should study mathematics with all your senses, from your sense of sight, taste, smell, hearing, or any other way that you can be aware of the influence of external stimuli. If you ever want to remember something, the best method to use is to cross-associate the idea with other stimuli so as to have the memory saved in multiple regions of the brain. This is why I used art to learn math. By placing equations and values into my painting, I converted an image that I spent a lot of time staring at into a cheat sheet for scientific and mathematical figures. Every time my eyes come across the math I put into the painting, it reactivates my memory of learning the equation or value. And every time one of these memories has been reactivated, the neural connection is strengthened between my brain and the knowledge of the equation. So there is a method to the madness, and this method of using art to learn math is madly more efficient than the brain molestation that students typically experience in formal academia. Now, just to give you guys a little bit of background, I didn't start all this stuff with the idea of following through with the painting. I actually was just doodling and drawing a couple optical illusions, and this ended up being the result. And it started off by me drawing impossible triangles, which, due to the lighting, or the shading, you can't tell what side is up and what side is down. So it's kind of a cool optical illusion, and I believe the creator of it was Sir Roger Penrose. And I drew a couple over here and a couple over here, and I just kept going with the triangles for a while and other optical illusions. And these are anamorphic holes. So it's a three-dimensional looking object on a two-dimensional surface. And I'm not very good at them yet. These are all just little practice ones. But, they're pretty cool, and they're a lot of fun to draw. And then I moved on to drawing some fractals like the Sierpinski triangle here, which is not done yet. And yeah, I'm a big fan of fractals. So I had to add the Mandelbrot set, which is here. And if you guys are also interested in fractals, or if you don't know what they are, please see the description below. Okay, I might be boring a few of you at this point, so I will go ahead and get started with explaining some of the equations, and I'll turn the black lights on for a little bit more visual effect. And we're back. And that's what it looks like with the black light on. I think it looks a little bit better. And I will start with this, 3.84 times 10 to the 8 meters. And I think that that was the first mathematical value that I put into this painting. And the significance behind that is that it's the average distance in between the Earth and the Moon. And I'll remember that for a long time, one, because I'm always looking at it, but two, because of where it's at in relation to the painting. It's in between the Moon and the Earth. So, you know, there are so many cross associations that I've made between this mathematical value and the painting and everything else that, you know, you could probably ask me what the average distance is between the Earth and the Moon 10 years from now, and I'll probably remember it. And you can't really say the same about the math that you learned in high school or college, because that stuff fades out of your memory fairly quickly. So now we'll move on to the next one. And now for the next equation. This is Isaac Newton's law of universal gravitation. And what this equation is saying is force equals gravity times the mass of object 1 times the mass of object 2 divided by the distance squared. Now, this equation is a direct result of Isaac Newton's experience with the apple falling from the tree. So, and it's a pretty profound equation. Don't take that one lightly. Most of the equations and symbols and values and almost everything in here has a purpose, why it was included. This one is different from the rest. This equation doesn't really have that much significance in the actual painting, but it did have significance in me relearning the order of operations to solve math equations. Because I started getting into some of these complex equations, you know, just like Isaac Newton's universal law of gravitation, and I forgot how to solve them properly. So I had to go back and do a review, and I came across a YouTube video by another guy, and he does a lot of math magic stuff, which I find really entertaining. But this was one of the equations that he put into his video, and the way he played it out is he tells you to pick a number between 1 and 10 or 1 and 100 or 1 and 1,000 or whatever he wants you to pick. And then he tells you to divide that. Okay, you know what? We'll just go through it. Why don't you pick a number 1 through 10? And I will pick 2, just so it's easy while I'm talking. And I will solve this equation using the proper order of operations. So my x is 2. So 2 times 2 is 4. Plus 8 is 12. Divided by 2 is 6. minus the original number, which for me was 2, so it would be 4. And the cool thing about this equation is that as far as I know, and I did try some really crazy numbers like 978,473 and a bunch of other ones, and it always still solved with the answer being 4. So this equation is math magic. You can use it exactly how it is right now to, I don't want to say guess, but to use your magic to know the number that other people are guessing, because it's always going to be 4 at the end. But anyways, like I said, that didn't really fit into the painting, but it was an important equation to me. I did find it fascinating enough to put in here, and that's why it's in. If you are watching this video on a Friday, I feel it necessary to tell you Happy Fibonacci Friday, because this is the Fibonacci sequence written out to however many iterations I could get it before it got into the inner spiral. So that's the sequence written out. And the Fibonacci sequence is a really cool one. If you don't know anything about it, I don't want to spend the time explaining it now, but you should definitely check it out. It's very entertaining. And for those of you who do know about it, and even if you don't, this is actually the Fibonacci rule. Fn equals Fn minus 1 plus Fn minus 2. So that equation is responsible for the Fibonacci sequence. Now, I am a big fan of math. I'm a big fan of science and anything else that's interesting. And I didn't know the symbols for some of the subatomic particles that I find interesting. So I thought I would throw them in here just to help me remember them. And they're actually really easy. They're very intuitive. Like this right here, the S with the line over the top, that's the strange quark antiparticle. Now all the quark antiparticles are denoted by having a line over the top of the letter. So, let's see, this is the regular strange quark symbol. And this is for the charmed quark. And this is the charmed antiquark particle. So I've got a couple of those all over. I've got some others like the electron and positron and some other cool symbols that I wanted to learn. And I know them now. Well, I think I'm done explaining these equations to you guys, because I think that if any of these equations or values or symbols or anything in here interests you enough that you actually go and look it up on your own, when you go through the effort of doing that, it is going to be ingrained in your head a lot more efficiently than it would if I just told you the answers and told you what everything in here means. So go do the work on your own if you want to know what's in here. There are some surprises, I can tell you that. But I will leave you on an explanation of the swastika, because I'm sure I'm going to get some backlash over that. Now, you can take all the symbols in the center of the painting however way you want to. They could be good, they could be bad, or whatever. But the swastika, I want you to know that it not only represents Nazism, but it also represents Buddhism. And those are two diametrically different not organizations, but ideologies. We all know what the Nazis did, and unfortunately less of us know what the Buddhists did. But the Buddhists are very peaceful and they're very scientifically minded. And the Dalai Lama in specific, he has a great mind for quantum physics and everything science and math. So that could be championed as both a good symbol or a bad one. You take your pick. But it does have significance in the painting.